Hello. Hello. Hi everyone. Myself Miss Poonam. By profession, I am a teacher. Before I say that write this down, I want everyone to visualize something. Consider yourself. You are sitting under the tree of a park. Look up. Birds are flying. On your right, people are walking in and out of the shops. On your left, vehicles are moving forward and backward along the road. And right in front of you, children are running, jumping and playing. What do all these things have in common? They are all in motion. Motion is the very rhythm of our universe. From the blood rushing through your veins to the earth spinning at the incredible speeds around the sun. Everything is moving. But here is my question to you. What exactly is motion? How do you prove to scientists that something is moving? You might say, ma'am, it's simple. If it changes its position, it's moving. But let me give you a brain teaser. Imagine you and your best friends are sitting on a luxury train traveling to a Delhi. The train is at 100 km per hour. You look across the table at your friend. Is your friend moving or at rest? From your point of view, your friend is just sitting there sipping juice and they aren't going anywhere relative to you. So you say, my friend is at rest. But now imagine your physics teacher, right, that's me, is standing on the railway platform watching the train zoom past. From my point of view, both you and your friend and the juice are flying past at 100 km per hour. So I say they are in motion. So who is right? You or I? So the answer is we both are. And this brings us to the most beautiful foundational concept in mechanics, that is motion is relative. Nothing in this universe is in absolute motion or at absolute rest. To define motion, we need a secret ingredient and we call it as the reference point or the origin. Let's break this down. Look at this diagram. If you change your position relative to a fixed point as time ticks away on your watch, you are in motion. If your position doesn't change relative to the point, you are at rest. Therefore, whenever you describe a motion, you must always answer the question, compared to what? That what is your reference point. In the train example, when the reference point was the train, your friend was at rest. When the reference point was the platform, your friend was in a motion. Beautiful, isn't it? Now, we know when something is moving, let's look at how it moves. Imagine you want to go from your house to the ice cream parlor, that is at point B. But there is this giant park present here. You take the road that curves all the way around the park. You walk, turn left, then turn right and then arrive at the ice cream parlor. The total length of the path you actually covered is called as distance. But what if you had a superpower? And what if could you like Superman in a perfectly straight line straight through the park from your house to the parlor? That shortest straight line distance from your start to your finish is called as displacement. Notice the difference. Distance is the total length of the path you actually covered and displacement is the shortest straight line distance from the start. It is the straight line distance from your start to your finish is called as displacement. Let's test your foundation brain before we close. You go to a circular track. You start at a point A. cover a distance of 400 meter and comes back to a point A. What is the distance you covered? Distance covered by you is 400 meter, which is a length of the circular track. And what is the displacement? Because your starting point and the ending point are exactly same, your shortest distance is yourself. That is 0. That means displacement is the 0. So you ran 400 meters, sweated out in calories, but in the eyes of the physics, your net displacement is 0. This is why physics is amazing and it changes how you look at the world. Thank you.